Welcome back to the sixth and last chapter in Algebra on Statistics Part 2. Previously, you learned how to draw a histogram, but there are a couple of cases where you would have to make a slight modification while drawing your histogram. So these cases I'm going to discuss in this section on Krink marks and class intervals. Let's say you've got a data set that looks like this. As usual, in your first column, you've got your class intervals for your marks, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. And in the second column, you've got your frequencies or number of students. The frequency for the first class is 5, then 20, 25, and 7. So what is different between this data set and the one that we saw previously when we drew our histogram? The answer is, in this case, the lower boundary of the first class is quite far from the origin, 0. So if we take this data set as it is and draw the histogram, it's going to look something like this. So this is our histogram right here. And notice that because our first class began at 60, there happens to be a big gap left in this area, which usually doesn't look good in a diagram. You don't want large open spaces within your diagram. This gap is a problem for us. So how do we go about solving this problem? We simply drag our histogram all the way to the left so that this class comes quite near the origin. That's going to be our solution. So this is what we are going to do. So now you can see we've dragged our histogram all the way to the left. So here we've begun numbering the x-axis from 60, then 70, 80, 90, 100, 110 and so on. But if you notice, now this is no longer in proportion. This distance is 60, right? Here is 0 and here is 60. But this width is only 10. So we need to account for all the missing distances here, because when we drag this histogram, all these 10, 20, 30, 40, 50 marks disappeared between the origin and the 60. So to represent those missing marks, we put a symbol that looks something like the letter Z. Okay, it looks like this. This symbol is called a Krink mark. So when you have data where the lower boundary of the first class is pretty far from the origin, then to draw your histogram, you will start numbering, for example, 60, 70, 80 and so on from the lower boundary of your first class very close to the origin. So you start numbering very close to the origin and you represent all the missing values that you've skipped by this Krink mark, this Z-like letter. Okay. So this is the first variation on drawing your histogram. When you have a data set whose lower boundary is far from the origin, you still draw it close to the origin, but you label this with a Krink mark so people know that you've omitted all these values 10, 20, 30, 40, 50 and you've begun directly from 60. Now the second variation on drawing histograms you're probably already familiar with from the previous chapter on Statistics Part 1. If you notice, we've got again the class intervals on the left in the first column and the frequency or number of students in the second column. But in this case, the upper boundary of our first class is not equal to the lower boundary of the second class. There's a gap. And if you remember how we had solved this problem, to make these discontinuous classes, what did we do to make them continuous? We simply drew new class intervals or new class boundaries in the midpoints of these gaps. So for example, here between 19 and 20, the midpoint would be 19.5. So we use that as a new class boundary. Similarly, here it would be between 39 and 40, there would be 39.5 would be a new class boundary. So let's put a new column in the middle and write down our new class boundaries. So this class interval will now be 0 to 19.5. Similarly, the second class interval is going to be 19.5 instead of 20, and here instead of 39 you will put the midpoint of this gap, which is 39.5. So the second class interval will be 19.5 to 39.5. Similarly, for the third class interval, the lower boundary is going to be the midpoint of this gap, which is 39.5, and the upper class boundary will be the midpoint of this gap, which is 59.5. So this is going to be 39.5 to 59.5. Similarly, the next one is going to be 59.5 to 79.5. And the last one will be 79.5 to 99.5. So these values are your new class boundaries. And notice that now they are continuous. So the upper boundary of the first class is equal to the lower boundary of the second class. The upper boundary of the second class is equal to the lower boundary of the third class, and so on. So all these new class boundaries have made your classes continuous. So you can go ahead and simply draw your histogram using the new class boundaries.